Testing, testing. There we go. Sound looks good at the moment. Hello, everybody. Welcome back. Advent of Code, for me, day 5. It's technically day 6. Welcome back to Coding Together. This is your stream where I, Savani DeJaranel, a professional programmer with 25 years of experience, show you just how much a professional can struggle on seemingly simple problems. Like for the last couple of days, been doing Advent of Code. We did 1 through 4 on stream. Skipped last night because I had some other things going on. Coming back tonight. And we're definitely going to do 5. We will do 6 if I get through 5 in just an hour. I don't know. I made mention last night that maybe I would start doing some of this ritual setup stuff before I came on stream. And so as you were watching the countdown, maybe, unless you were on YouTube, in which case I tend to trim the countdown out, I went ahead and set this up in just the minutes beforehand. So you don't have to wait for me to get that started. And now we're going to verify that I set it up correctly. Just make sure it all compiles. Nope. No, I didn't. Awesome. What did I do? Oh, yeah, that's what I did. Haha. Maybe one day I'll go through and figure out a better way of doing things. I was sure that yeah. Check that my resolution is good. It is. There we go. Okay, everything compiles, so let's have some fun. Let's go back. Let's look at Advent of Code. I took a very quick peek at today's problem. Looks like it might be something like a graph traversal. Not a complicated one, but a little bit of one. Or I guess it could actually be called a dependency tree, which itself is a form of graph traversal. So, as you might recall, on day 4, we were at the Ceres monitoring station, or the Ceres asteroid station, not sure which. But we are finished with that. Satisfied with their search on Ceres, the Squadron of Scholars suggests subsequently scanning the stationary stacks of Subbasement 17. Somebody got very cute with alliteration there. The North Pole printing department is busier than ever this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. The elf must recognize you because they waste no time explaining that the new sleigh launch safety manual updates won't update correctly. The new sleigh launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your services, or I offer my services. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation, this X vertical bar Y, means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. So this elf has for you both the page ordering rules and the pages to produce in each update, your puzzle input, but can't figure out whether each update has the pages in the right order. Cool. So test data right here. This is all of the dependencies here. So this means that, okay, page 47 must be printed before page 53. And like page 97 has to be printed before 13. So this is going to be like a long line of dependencies. Or maybe not even a line. I think it's going to be a tree. Yeah. Well, might even be more complicated than that. 13. I'm not really sure how I'm going to solve this one yet. I have to think about it. It's going to be pretty simple once I stumble upon the right answer though. And then here are the manuals: Manual 1, Manual 2, Manual 3, Manual 4. Have to figure out which ones are correct. And then the actual thing that we want, I read down already, is we want to grab the middle number of every correct manual and add them together, and that's going to be my puzzle result. Not at all straightforward. This is very convoluted here, but it's going to be fine. Going to be totally fine. So, as is normal, grab all of the data, copy it into a test data structure, or a test data and I want a parser for it. So we'll just say fn parse parse input. And I don't actually know what I want to return. So we'll say struct dependencies and struct manuals. I want to return a tuple of dependencies and vec manuals. And this is unimplemented. Then I want to write my first test. So we'll do a test. Fn it finds correct. Well, actually, the very first test is going to be it solves part A. Let result equals unimplemented, and then assert EQ that result is 143. Which, okay, cool. That's fine. I want to give this a name. We'll say fn part A. We'll give it dependencies. Yeah. Deps, dependencies, and manuals, vec manuals. And this is going to return an I32. And we're just going to return at this moment 0. So technically the test should compile. Result is going to be part A of let deps manuals equals parse input test data, and then part A of deps manuals should be result, which really will make this part a one-liner. Okay, so it looks like everything would compile just fine. It should be failing, and it is. Excellent. Now, one thing I forgot to do before starting is I want a bit of music, so I'm going to get that going. I can't share it, copyright restrictions and everything, but it does kind of help me out with thinking. And what am I going to listen to tonight? I'm going to go with like really cheerful and do some Lindsey Stirling. That should be fun. So if you wanted to listen along, you could pull up the Artemis album from Lindsey Stirling and start listening right about now. Cool. There we go. Okay. everything is set up. Continuing on with the work. There we go. Now it's finally low enough for me to really be able to think again. So step 1, determine that I found the correct manuals. So fn it finds correct manuals. So we'll say let deps and manuals equals parse input test data, as always, and then let, is it safe or is it valid? Yeah, I don't care. Let safe manual, or let safe equals safe manuals, and feed the data in. Assert that safe is safe.length is equal to 3. Safe 0 is going to be the manual which contains 75, 47, 61, 53, and 29. Then we'll do the second one, 97, 61, 53, 29, and 13. And then the third safe manual will be 75, 29, and 13. So now I know what I want a manual to be. It's basically just going to be a vector of I32s. Okay, now in order to get this far, we want to do the parser. And since I've already introduced nom-parsers, I'm going to go ahead and introduce it again. So fn parse page number takes an input of a string, and it returns an iResult of type. Now I have to look up day 4 or day 3. It's going to return an iResult of string, the input type, and an I32. So in order to do this, if we have one line, I don't remember how to, I think there's a combinated, or a parser that will just give me an I32. Rust nom. Oh, right. No, there's not. These parsers, I16, I32, those are for parsing binary representations, and these are string representations. So I'm not going to use that. I'm just going to say isDigit. So let input page number equals is take while. Yes, take while is digit. In fact, I don't even want to do that. I just want it to be this simple statement. And then fn parse and then fn parse dependency is going to be string i32 i32. And so for this, it will be page A input, comma, page A equals parse page number input page B, and we also need to put the separator in there. Okay, now something you might notice is that on each of these lines, I am overwriting the input value, and that just makes it very convenient to be able to add additional lines. So we take the input from, or the input parameter to the function, we pass it to the first parser, and then overwrite it so that we can just use the same variable name when passing it to the next function. That's actually really, really common with nom parsers. I learned to do it when I was learning nom parsers, but I just wanted to clear that up in case it ends up being confusing to anybody. Cool. Okay, so parse page number is actually incorrect. We'll come back to that in a moment. And I'm probably going to come back to this in a minute and find better names for page A and page B. So let input digits equals take while is digit input. Gotta parse the digits. Otherwise, it's just going to be a string of numbers. That should be good. There's a type mismatch. String as input take at position item. Huh. What is this telling me? Expected a character found a U8. Expected a character found a U8. What is the type of is digit? Oh. This error message I think is a little bit misleading because isDigit actually wants a U8, not a character. Rust car to U8. I hope this doesn't end up being complicated. Can't find a way to cast a car into a U8. That That might be bad. Oh, car represents a Unicode. Okay, it is safe to just use an as conversion here. It's a little annoying, though, that maybe I'm not... There might be a better parser to use. Like, there might be a bytes version of the isDigit parser. Or I could just switch everything over to being an array of U8 instead of stir. That's actually really tempting. Let's do that. We'll leave it as a stir right here. We'll make the conversion there. But by the time we get into here, we're expecting slices of U8. Gotta include iResult apparently. There's a method parse2 with a similar name. This should go away. Just close that. Oh, it doesn't like that. I'm going to look back at the parsers again, because I know that I've done this without having to do any weird contortions in the past. Oh, wait, there's an even easier one. Yeah, there's a parser that just handles this. I don't even need the take while. Import that. Why do you keep not having it? Okay, there we go. Okay, these are never being used because you're doing a full-on dependency analysis. So this will get us all of these lines. Now this is... I was going to say this is too simple for a parser, but in fact there's a very simple non-parser for this. Parsing a manual. It's going to be, I believe, separated, not separated pair, separated list, right? Tag that. Separated list requires a separator, and it requires the function. I believe this function, yes, this function is a parser, which means actually, we're going to go with the separated list 1 version. The difference between the 0 and the 1 is that the 1 version must return a value, whereas the 0 version could return no values. not quite. Did not quite work. It expected a function closure, found a string, the trait. Parser separated list. Oh. That has to be a tag. It can't just be. Yep, there we go. That's fun. It also means that dependency can be simplified a bit more. But I'm not going to. I am going to have the dependency row go ahead and consume the trailing new line. Yes. Cool. And instead of page A and page B, I'm going to call them, I guess, predecessor and successor. Okay, and then the actual manual, or not the actual parse function here is going to be take while. Oh, this could be fun. I could actually remove that. I'm not going to at the moment. But like I could remove this line ending parser. I want to take while no. So take while is alphabetical will return that oh wait, I think I can just say many one. So if I call many one and right, I'm going to call it on parse dependency with input. And then here I'm just going to unwrap things. And instead of parsing the next part, I'm going to print out the dependencies just to be sure that I got it right. Yes, perfect. That is working exactly as I expected. So we parse dependencies, then we need to, I believe we're going to just consume a blank line. And then I want to parse manuals. Why didn't it like line ending here? Yeah, I didn't think that would be valid. We'll just make this a string. I don't know that that's a, yeah, that's not. It has to implement parse error string. I'm going to make this a little bit simpler on myself. Parse input underscore should return an I result. I don't recall now how I ran the parser. Parse input, we run this on the input data and then we call finish. Huh. Did not expect that to be the right answer. It makes me really wonder if I understand how this finish function works. It might be that this is on the parser trait, and I'm not necessarily directly associating this function with that trait, even though I know that this function implements the parser trait. The type checker might not be able to figure that out. Only got one manual. Oh yeah, that's because I didn't consume the line ending. Let's see though if, I think it's ends with, maybe it's not delimited, separated, terminated. And it should be terminated with first, second. So gets an object from the first parser, then matches the second parser. So terminated parse manual line ending. There we go. That's a whole bunch of manuals there. Sometimes Advent of Code is just learning how to practice parsers. I'm going to go ahead and discard the input. No, I'm not, because I need to return it in order for this to be a valid function. Dependencies is still an empty data structure. Okay. Now, though, it's time to figure out what dependencies is going to be. So let's do a bit of like graphing here. I do wish I could like write on the screen, but that really requires that I have a working or the ability to plug a tablet in, and there's not enough ports on my machine. So we're just going to do it in comments here. So we know that page 47 must precede page 53. We then know, oh, wait. Wait. I know a way to make this good. We'll go over to Mermaid.js. I'm sure that there's a playground on here somewhere. Tutorials, integrations, contributing. Is this what I want? No, this is just getting in my way. I'll find my notebook here and open a new, just open a new diagram. Theoretically, my notebook opened, but it did not open any windows. I'll be back in just a moment, just in case. There we go. That was unintentional. My notebook opened like directly on the window, and even though it was just a bunch of notes for a role-playing game that I'm running tomorrow, I didn't really want to make that visible. So we're going to do a mermaid graph right here. Graph top down. Start zooming in on this so that it's really more visible. So we know that 47 needs to precede 53. 97 needs to precede 61. It also needs to precede 13 and 47. So there's a bunch of things. Oh, okay. So here we have a dependency graph. So I think I'm probably going to want to invert the graph. I think that whenever I run across a number, I want to make sure that everything that comes before it is already present. The way okay, sorry, I just redescribed the entire problem statement there. But I think the way we do that, we know that 29 needs to come after 53 and 61 and 47. We know that 53 needs to come after 97. So if we have a manual that looks like 97, 53, 29, we can go forward one step, making sure this is really visible. I think it is. Let's zoom in a little bit further, just in case. There we go. We get 97 in there. So I'll mark it with a hash set. I'll just call it 97. There is a rule that I have forgotten that applies to like nothing precedes it. Like if 97 normally has a dependency, but there's something about bootstrapping the first one. We're going to ignore it for the moment. We're going to assume that 97 has no dependencies. So 97 appears, we've marked it in there. We then hit the number 53, and we find 53 in our chart, and we know that it must come after 97. So we check our hash map, and we see 97 is already in there. So that's cool. We can add 53. Then we hit 29, and we know that 29 must come after 47 and 53 and 61. 47 and 61 don't exist, but 53 does, and 29 comes after 53. Let's check the rules again, just to make sure I got it right. Okay. Dates are already in the right order. The above example, yes. Where were the rules again? Has for you both the page ordering rules and the page to produce. Okay. To get the printers going as soon as possible, start by identifying which updates are already in the right order. Because the first update does not include some page numbers, the ordering rules involving those missing page numbers are ignored. So this 75, 47, 61, 53, 29, this is the first manual update here. 75 normally must come after 97, but 97 is not present at all. And because 97 is not present, then we ignore that rule. But if 97 was present and it came after the 75, then the update would be wrong. So we have two things that we need to check here. First of all, we need the hash set of like everything that is present. So we know that 23, 53, and 97 are present. And we do that without even checking the dependency graph. Then we look at 97. It has no dependencies, so it just, what we could, No, we'll stick to this. So 97 is present. It has no predecessors. 53 is here. Its only predecessor in the chart is 97. That's already present. So we say, okay, we've got 53 as well. And then when we look at 29, we first see that 47 is not even present in the data set. 61 is not present in the data set, but 53 is, this one right here. And then here we can see that 53 is already present. So, present in data set, and then preceding numbers. So I'm going to write this. So checking 29, we look to see what numbers 29 must come after, which are, with this with this very small chart, 47, 53, and 61. Then we check numbers present in the data set, which is 29, 53, and 97. So the only number that 29 depends on in this data set is 53. Checking preceding numbers, we can see that 53 precedes, we can see that we have already encountered 53. Okay. I think that gives us a good start, but we're going to check each one of these, like they tell us what the result is for each manual, because there might actually be another subtlety where if we had like if we had 97, 53, 29, 53, I don't know if this is a valid manual right here. So okay, first update is in the right order. Okay, according to this, first, second, and third manuals are each in the correct order, so, or basically they're all safe. Is safe. We're going to assert that manuals 0, 1, and 2 are safe. Then this one is not safe. This one is not safe. And then the last one is also not safe. Expected 3 arguments, found 2. What? Oh. And I need to borrow each of those. Cool. Okay, now it's just to get this particular isSafe function working, and everything else will fall out. The way I want to do it, probably just bring in a B-tree map, I think. An ordered map based on a B. Oh. Yeah, I don't care about that at all. Actually, a simple hash map is going to do this. So type dependencies equals a hash map where the key is a number and then the data stored is all of the numbers that have to come before it. That should work. So now we've got there's going to be a dep list. So now I want to traverse over this. Let deps equals dep list. No. Let mute deps equals hash map new. For predecessor successor equals dep list dot into iter. We'll just consume the entire list. I want to say deps dot entry successor and modify for good measure, we'll make this one a hash set. Because why not? Let's just enforce uniqueness. Okay, that was a lot to write in a single chunk. Okay. So I need to consider giving this closure an explicit type. I'm not sure. Predecessors is a mutable reference to a hash set. Yeah. Huh. How do I populate a oh, right. This is one of those weird things. Populating, initially populating a hash map and a hash set. There's not like explicit functions. You have to do the convert to an iter or like convert to an iterator and then collect it in the different type. It's one of these areas of Rust that I feel is a little less intuitive than it should be. Okay, why is this not working? Oh, right. What does and modify do? Fn wants mute v. This is a little weird that it's not figuring out data types. And type must be known at this point. It should be known. Huh. Okay, well. Or hash set I32. No method named add. Is it insert? Yes. what do we have for the dependencies? Less than I expected. 53 depends on 75, 47, 61, and 97. $53 depends on 75, 61, 97, and 47. 75, 47, 61, 97. Perfect. Yep, that's right. And then later on, 29 depends on 53 and others. Awesome. That's great. So the rest of this should fall over pretty quickly. So is safe. So let values present, a hash set of i32 equal manual.iter.collect into that. This is better syntax when I can do it. And then then let's say let values counted hash set i32, or will hash set new, that should do. And then now for page in manual.iter, where I must have hit page down. Okay. So we've got a page. Then I need the let page deps equals deps dot get page, and I'm going to just assert that it's going to be found. So that's the hash set of i32. So we want to run over each element of that. For page dep in if values present dot contains page depth if values counted dot contains page depth. Actually, if it does not contain it, we're going to return false. Then we're going to return true. So what this is saying, first of all, we grab, well, this is clearly wrong. Grab a page from the manual. If for each dependency that this page has, we're going to first check if the dependency is present. If it's not present, we just move on to the next dependency. If it is present, we check that it has that it has already arrived. And if it has not arrived, then we bail. And I think that's it. And it appears that there's a problem right here. Yes, I think I need to clone each of the items. Is that the right thing? Yes. Then values counted. It doesn't know what it should be. Now, it would be great if I see that test just pass this time. It finds correct manuals. It checks manuals. It did not pass the checking manuals. Assertion is safe. Manuals 0. Well, that's not great. I'm just going to start putting some debugs in. We'll see which pages it gets around to checking. And in fact, I just want to focus on that test. Can I do that? It checks manuals. Yes, perfect. So we check page 75. That one passes. We check page 47. That one fails. Okay. Why did it fail? And then let's see how far we get here. So we're checking the page depth. The page dependency is not present, so it bails. Okay, so 75. Now 75 should be present. Oh, I'm not populating values counted. That's that's really silly. And in fact, I want to always insert it right after this. Still not right. But I got a lot further. Which one did it fail on? There's an unwrap on a none value, 34. Oh, 97 is not going. 97 I don't think appears on the right side. Okay. So instead of unwrap, it'll be unwrap or vec 0. That's not right. And hash set new. So for those things that don't ever appear on the right side here and thus don't have any dependencies, we want an empty hash set. Yet I don't think that what I'm doing here is valid syntax though. Okay. Empty hash set is going to be a hash set of I32 empty deps. And we're going to borrow it. There we go. And pass. Test passes. Excellent. I'm going to take my debugging out. So if that test passes, the next step is figuring out the center value. So I need to know the middle page number of each update being printed. Or of each valid update. So middle page is going to be very easy. Fn middle page of a manual. Since apparently all of the manuals are odd or have an odd number of pages. So let center IDX equals manual.len divided by 2, which if it's 5 and we divide it by 2, that'll be 3. So we actually want index, no, 5 divided by 2. 5 divided by 2 is going to be 2.5. So we want index 2. Let's check something here because I don't remember what happens if I do just plain integer division. Print 5 divided by 2. Run that. It returns 2. Okay, so it just truncates. Is that correct? Yes, that's going to be the third value. So manual center IDX. We could technically make this a one-liner, but I'm not going to. Let's quickly check it. So of the 3 safe ones, middle page of we're going to assert that the middle page of manual 0 is 61. Manual 1 is going to be 53. Manual 2 is going to be 29. I'm going to restrict the tests down to day 5. I should have thought about the fact that that was possible. Whether it's possible or not, I've done it wrong. Okay, we're finding the center values. So since we know the center values, we can figure out part A, which is going to be, we've got the dependencies, we've got the manuals. We're going to manuals dot into iter filter is safe. Is this manual safe? We filter it down, and then for each one we're going to figure out the middle value or the middle page. And then we can fold it. So we start at 0, the accumulator, and the page number. We return the accumulator plus the page number. And we just did that entire thing there in a single line. Except that I did this wrong. That's fine. It finds the correct manual. I never actually wrote the code to find the correct manuals. Oh, well, that'll make this a little bit simpler. Safe manuals. Let's bring this up. We'll just extract some of the part A function into here. So manuals.intoiter.filter is safe. And for the fun of it, I'll make it return an iterator. IMPL iterator item equals manual Oh, it still didn't like it. Force the closure to take ownership of depths. I don't want it to take ownership. Wait, what? Let's fix this one. Why? May outlive borrowed value depths. Why would it outlive that? But I don't want it to take ownership. Oh, and now we've got lifetime problem. Okay, no, I'm just gonna eliminate that function completely. I don't want to work out lifetime problems tonight. So we'll take out the it finds correct manuals. Well, we won't totally take it out. Maybe in part 2, I'll have to find the lifetimes. Okay, cool. I have all of my tests passing, so now I'm going to load up the day 5 data. And we're going to run 5A. Where's my terminal? There it is. Cargo run 5A. Don't crash, don't crash. Perfect. So we'll plug this in, make sure that we got the right answer. There we go. So I'll go ahead and add that to my part A assertion. And rerun my tests. Not quite, because I typoed it. I'm not sure how I typoed it, but I did. There we go. Okay, let's go on to part 2. Let's hope part 2 takes less time. Okay, so while the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. For the above example, here are 3 incorrectly ordered updates and their correct orderings. Okay. After taking only the incorrect ordered updates and ordering them correctly, their middle page numbers are 47, 29, and 47. Adding those together produces 123. So I'm going to add test fn it solves part B. Obviously, I can't write those lines yet because I don't know what the answer to part B is. But I know this one, so 123. Okay, now let's go find part B. So in this one, actually, we can already express the top, which is manuals.intoIter.filter manual only the unsafe manuals. And then over each one, we want to fix the manual using the dependency rules. And so we know now that fix manual is going to have to return a manual. And then we're going to go back, and I'm just going to copy these two lines. Yeah, so the only thing new is going to be this fix manual function. And I don't know how I'm going to solve it yet. Got to think for a few minutes. Okay. The test was easy enough to write. I think, though, that what I can do is, let me grab one of these data sets. This one. So copy that. So this is the set of numbers. Probably I'm going to have to go through and build another of these graphs in a moment. But I think that what we can do is just grab, like basically just build a hash set of this. So we start out with 97, 75, 40, 61, 53, 47. And then for each element of the hash, no, I don't have it yet. Oh, okay. Hang on. So I know that present in data set is that. And I know that 97 precedes 75 by this rule. So I look at 75, I know that 97 is already present. Or sorry, that 97 is present. So let's see here. starting at the beginning of the list. Or really, I could just start. Let me flip this around. 47, 53, 61, 75, and 97. And now let me build a dependency tree for this. And I know it's tedious, but this is how we think through it. Okay. 97 has to precede 47. 47 has to precede 53. Let's see here. 61. 97 has to precede 61. '97 has to precede 47. Oh, I already got that. 75 has to precede, probably not relevant, 75 to 53. '75 to 47. 75 to 61. 75 to 13. That's probably not relevant. Okay, looking at 47. We already got 47 to 53. 47 to 13. And 47 to 61. And 47 to 29. And this is the opposite of this graph that's right here. I've inverted the whole thing. That's a mistake. Now I have to start over. Okay, 75. All of the things that must precede 75. So we have 97 is the only thing. Now, all of the things that have to precede 97, there are none. That's good. All of the things that have to precede 47. I don't know why I'm doing it this way. I have a way to print all of this. If you were screaming at me because that was obvious, yes, sorry. Copy that. Paste it right here. Still going to turn it into a diagram though. Okay, let's see here. 75 only depends on 97. Great. 97 depends on nothing. 47 depends on 97 and 75. Then 61 depends on 97, 47, and 75. And then 53 depends on 47, 75, 97, and 61. Great. So if the first thing I do is I look at 75 right here. So look at 75. 75 depends on 97, which is present. So recursively handle 97. 97 depends on nothing. Put it into the list. Now put 75 into the list. Now we need to put in 47. Look at 47. 47 depends on only things that are in the, well, I already filtered this whole thing down to just the things that are in the list. 47 depends on 60, 61, and 53. So recursively handle 61. 61 depends on 53. Recursively handle 53. Oh, wait. No, I did that wrong. I'm reading it in the wrong direction. 61 depends... Ooh, wow. Okay, 47 depends on... It's right here. 75 and 97. Both are already in the list, so add 47. Now we look at 60. We'll say we look at 53. 53 depends on 61, 47, and 97. So we recursively handle 61. 61 depends on 47, 75, and 97. All three are in the list, so add 61. So now 61, 75, and 97 are in the list, so add 53. So I think that's the general procedure. It basically comes down to grab a number, then grab all of its dependencies, which are present in the manual update. If all dependencies are already present in the list, add the number. Otherwise, recursively handle each dependency that is not in the list. When popping out, check whether a set of dependencies has been fully handled, or something like that. It's this idea of like, if things had come in a different order, I might have processed 61 before 47, like might have gotten 53 first. And in processing 53, we process 61, or we need to process 61, 47, and 97. We happen to start out with 61. That ends, processing 61 handles 47 and 75. So when we pop back out to 53 and we're about to jump into 47, we find that it's already present. And so we just don't want to handle it again. Otherwise, we'll end up duplicating numbers. By the way, it's been almost 2 hours, so I am very definitely not going to be doing Advent of Code 6 tonight. Oh boy, this has been a long one. Kind of unexpectedly. I didn't think that this would be hard. So if the manual is broken, I'm not even going to try like fixing it. I'm just going to take all of the numbers and arrange them correctly. So figure out the values present. We figure out the values counted. Let mute result. Let me check something. Rust vec. There might be a contains function already. Yes, there is. So I'm not going to bother keeping the values counted. I'm just going to keep the result. Ba, ba, ba. So for values present, oh, this is going to be weird to some degree. For value in values present dot iter, pages present. Let's keep the theme. Let's keep the theme. Let page deps equals deps dot get page dot unwrap or empty deps Okay, so I know the page dependencies. For page dep in page dependencies, if result dot contains page dep, actually it's if not result dot contains page dep, we want to handle page dep, for lack of a better word. Lot to unpack here, and as part of unpacking, we actually write the code to do it. So let's see here. Here's where I'll put the recursion. So we're going to handle a page. Handling a page means that we have to update the result, and we need the pages present, and we need the set of deps. Fn handle. There's a borrow that is, let's do that. And it doesn't like page. Okay. There we go. So we're going to get a page. I'm going to recreate empty deps every single time. Hate doing it. Going to do it anyway. So once we've gotten through this, I'm going to Okay, I'm going to write like one more line of code before we reanalyze this. But this line of code is the important one, which is going to be result.append page. Result.push. And don't need to do that, just need to do that. Okay, so we grab the first page from the list. Oh, you know what? No, the test fails. Oh, hold up a second. Had an unexpected visitor there, but also means I have a coding companion. He's just going to hang out with us, aren't you? You want to eat the microphone? No, you're just going to sniff the microphone and then look at mama. Ooh, dog breath. There we go. Okay, back you go. Okay, cool. So working through this again. For each page that is present, don't care what order it arrived in. I just want to know the page that was present, all of the ones that are present. We are going to handle that page. Now, handling that page means for every dependency that it has, if that dependency is not present, we want to handle the dependency. Oh. We only handle the dependency if the dependency is present in the overall data set. So if present.contains page dep and important one, if the result does not contain it, then we want to handle it. That's the recursion. Now that means that once we've gone through all of the dependencies, all of the dependencies should be present. That's kind of the assertion that we're making here. And so then we can just push the page to the end of the list. And it doesn't solve the problem, unfortunately. Bummer. Let's find out why. Uh, 97, 75, 47, 61. Okay. Yep, I'm failing to deal with duplicates. Okay, cool. Yeah, I even made a point of that, and then I didn't find a way to express it in here, because what's happening is it's processing something that depends on 97, maybe even transitively. So that's getting 97 added in, and then once it's done processing that thing, eventually it gets to needing to process 97, and it's like, okay, everything is there. Actually, this should be pretty easy. If result.contains page will do nothing. If it does not contain the page, we will push it onto the end. There we go. So let's see if that solves part B. Oh, yes, it does. Okay. 5B. Not implemented. What is not implemented? Oh. Okay. Where's Advent of Code? There we are. And there we go. We got it. So I'm going to go ahead and add that in here. Make sure that my tests still run now that I've added another test case. Cool. Okay. That's day 5 done. I'm going to peek in at day 6. Okay, so the historians use their fancy device again. This time, whisk you all the way to the... Okay, I'm not even going to read the story right now. So we've got a map, which is this. Map shows the current position of the guard to indicate where the guard is. To indicate the guard is currently facing up from the perspective of the map. Any obstructions are shown as that. Lab guards in 1518 follow a very strict patrol, which involves repeatedly following these steps. So we're going to be having a guard moving around. Following the above protocol, the guard moves up several times until she reaches an obstacle. There's now an obstacle, so she turns right. Reaching another obstacle. She turns right again, heads south, and then leaves the mapped... Wait. Okay, basically, when she hit right here, so she turned right, hit here, turned right, hit here, turned right, 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 and then left the map. Okay, so running around. So we can determine where exactly the guard will have been. How many distinct locations? Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? This should be really easy. Because I've already written the grid code. And I've got traversal code for it. Okay, well, not tonight. Anyway, if you've stuck around this long, thank you for watching the whole thing. I've been failing to actually upload my previous videos. I'll try to get them all caught up, so you might actually get just kind of, if you're watching on YouTube, you might just end up getting bombed with a bunch of videos all at once. But if you liked this video, like it, subscribe. Wow, I've actually requested that for once. Really, the thing that I'm most interested in is just any comments that you have, things that you'd like to see, things that you want me to do better. I can't promise to ever program faster, especially as I'm trying to explain my thinking as I go along. But things that you liked in here, I would love to know what you liked in this video. And again, if you stuck around for the whole thing, thank you. It's kind of wonderful. I would love to know. Other than that, I am going to skip tomorrow night because I'm running a role-playing game during the day and therefore will not have the energy to do any more talking to anybody afterwards. So I'll be back on Sunday night and we'll solve day 6, even though it's Sunday night, tomorrow's 7. Yeah, so I'm going to be behind by several days. I'm probably just going to stay behind until I hit my burnout point. So we'll do day 6 on Sunday night, and I think that's it. Yeah, that's it. So thank you all for watching, and nah, he's asleep. I won't disturb him. So again, thank you all for watching, and good night to you.